Lesson 6.1 is called inverse circular functions. And particularly, we're going to focus on inverse sine function, inverse cosine function, inverse tangent function. For 6.1, first we need to understand the definition for inverse sine function. The representation of y equals sine to the power of negative 1x or y equals arcsine of x. So they both mean the same thing. It means that when you look for the x value, x will be equal to the sine of y. So here, y and x, they will be inverses of each other. If y is equal to inverse sine of x, that means x will be the sine of y for any y value between negative pi over 2 to the positive pi over 2. This part is important. This is the only interval that you can locate your inverse sine function. Inverse sine is only defined between negative pi over 2 to the positive pi over 2. Think of y equals sine to the negative 1x or y equals arcsine x as y is the number, the angle in the interval negative pi over 2 to the positive pi over 2 whose sine value is equal to x. So what happens is with these questions, they gave you the sine value of an angle, and it will be your job to figure out that angle who has that sine value, and your answer can be only between negative pi over 2 and to positive pi over 2. Here's an example about what we're trying to say. So find y in each equation. So equation we're given is y equals arcsine of 1/2. So if I think about this problem in English language, so basically it is saying that give me the angle y whose sine value is equal to 1/2. And don't forget that y can only take values between negative pi over 2 to the positive pi over 2. So this equation can be rewritten as if arcsine 1/2 is y, that means sine of y is 1/2, and y can only take values between negative pi over 2 to the positive pi over 2 because this is the definition of arcsine function. So because of the unit circle knowledge, sine pi over 6 is equal to 1/2, and this is the only angle in this interval whose sine value is equal to 1/2. And this is how we're going to solve these questions. Here's our second example. Y is equal to arcsine of negative 1. So if you want to rewrite this equation, we can change it as, that means sine of y is equal to negative 1, and y can only take values between negative pi over 2 to positive pi over 2. The only angle whose sine value is equal to negative 1 in this interval is negative pi over 2. Just make sure that these two endpoints, they are included in the options for y. Therefore, the only expected answer here will be negative pi over 2. So when you see a question like this, sometimes, maybe even in the homework, if the sine value here is not a famous sine value that you were supposed to memorize through the unit circle, you will have to just enter your problem to the calculator and you will find the answer. But here, we don't need to use the calculator. Sine values are always restricted between negative 1 and positive 1. For any angle, sine value cannot be more than 1 and less than negative 1. So if you're looking for an angle whose sine value is equal to negative 2, such angle does not exist. Because for any angle in trigonometry, sine value cannot be less than negative 1. Negative 1 is the lowest you can get for a sine value of any angle. And if you put this question to a graphing calculator, you will see an error message because sine cannot take more than 1 or less than negative 1. So inverse sine function, you don't have to worry about its graph. I will never ask you questions about the graph for arcsine of x. But it is a good idea that domain is the values you can use for sine. And then domain is negative infinity, negative 1 to positive 1. And range is negative pi over 2 to the positive pi over 2. So if you evaluate arcsine of x for some famous sine values and find the corresponding angles, now the x values, the sine values, they become the x values, and the angles, they become the y values, and you can obtain the one cycle of arcsine of x. And this slide shows you what does arcsine of x looks like. And if you understand the attributes for this graph, the inverse sine function is increasing and continues on its domain. So it's very important that inverse sine function is continuous on the domain of -1 to +1. If x-intercept is 0, y-intercept is 0, the graph is symmetric with respect to origin because it's an arc function. So for just like sine function, when you have arc sine of -x, it's always equal to negative arc sine of x. So for inverse cosine function, many things will be similar to inverse sine function, but now the notation will change as y is equal to arc cosine of x, or y equals in cosine to the -1 over x, or arc cosine of x. It means if you are solving for x, x will be always equal to cosine of y. And this time, these numbers will change for arc cosine. So the y can only take values from 0 to pi, and both 0 and pi, they're inclusive. Think of y equals cosine to the -1x, or y equals arc cosine of x as you're looking for the angle in the interval from 0 to pi, whose cosine value is x. So whatever the number here given you is the cosine value for the angle you're looking for. So that's how you're going to answer these questions. Here's the example. We have y equals arc cosine of y. So if I think about this question in English, I'm looking for the angle whose cosine value is equal to 1, and I can only use the angles from 0 to pi because of the domain of the arc cosine function. So the book says that when you see this question, you can rewrite your equation again. If y is equal to arc cosine 1, that means cosine of y is 1, and y can only take values from 0 to pi. And since cosine of 0 is 1, that means the angle you're looking for is 0. So the answer for this question is the y must be a 0. So 0 is equal to arc cosine of y. Or for angle 0, the cosine value is equal to 1. Very similar question. We're looking for the angle whose cosine value is equal to -√2/2, and we can only use the values from 0 to pi. Since the cosine is negative here, and we know that in quadrant 2, cosine is a negative number. So cosine to the pi over 4 is -√2/2. So the answer this equation is going to return is to the pi over 4. Don't forget that for inverse cosine function, domain is same as arc sine, which is -1 to +1, but the range changes from 0 to pi. And then this is what the one cycle of arc cosine function looks like. And these are some sample values for arc cosine function to understand how the graph is generated. Now, if we understand the attributes for inverse cosine function, the inverse cosine function is decreasing and it's continuous. So if you look at this, this is a decreasing function and it's continuous. Its x-intercept is y1 and y-intercept is pi over 2. And then this graph is not symmetric with respect to the y-axis nor the origin. And then the third function we need to understand is the inverse tangent function, which is y equals tangent to the power of -1x, or y equals arc10x. And its domain is from -infinity to +infinity, because remember, for any angle, tangent values can be any number from -infinity to +infinity. But the range will be -pi over 2 to the pi over 2. So this is almost the same range as inverse sine. But for inverse sine, these two endpoints are included. But for inverse tangent, these 2 points are not included because these are the asymptotes for tangent of x. So if we look at some values for arc10, for when you have -1, this will be the angle whose tangent value is equal to -1. This will be the angle whose tangent value is equal to -3/3. For angle 0, the tangent value is 0. For this angle, this is the tangent value, and for this angle, this is the tangent value. And for arc10 graph, if you locate your x values and corresponding y values, this is what the arc10x looks like. And then just make sure that you will have an asymptote at -pi over 2 and +pi over 2. These are now horizontal asymptotes. Your graph is going to get closer and closer to this range and this range at the bottom, but it's not going to touch because they are called asymptotes. And if we look at the attributes for inverse tangent function, the inverse tangent function is increasing and it's continuous on its domain, which is negative infinity to positive infinity. X-intercept is 0, y-intercept is 0. And the graph is symmetric with respect to origin, so the function is an odd function just like arcsine. And the lines pi over 2 and negative pi over 2 are horizontal asymptotes. And we have to always keep in mind when we are solving these questions, y equals tangent to the power of negative 1x or y equals arctan x means that you're looking for the angle whose tangent value is equal to the x. And the angle will be noted as y. And the angle can only take values from negative pi over 2 to the positive pi over 2. And those two endpoints are not included. Similar explanation for inverse cotangent. Domain is same as inverse tangent, but the range is now almost the same thing as inverse cosine, endpoints are not included. For this one also we have two horizontal asymptotes, pi and 0. Your graph is not going to touch to 0 and pi. And if you look at this chart, very important when you are doing the homework about 6.1, for inverse sine function, domain is -1 to +1, and range is negative pi over 2 to positive pi over 2. That means the answer can be either in quadrant 1 or quadrant 4. For inverse cosine function, domain is again -1 to +1, but the answer you will be looking for belongs to 0 to pi, which means quadrant 1 and quadrant 2. For arctangent of x, the answer can be located in quadrant 1 and quadrant 4, and so on. For inverse secant of x and inverse cosecant of x, look at domain has a gap from -1 to +1. That means the range is going to change accordingly, because since secant is 1 over cosine, you can't use the x values, which makes your cosine equal to 0. Okay, we're going to look at some of the examples here. Find the degree measure of theta if it exists. Theta is arctan 1. So this question says that who will be the angle whose tangent value is equal to 1? Remember, you can only use the angles from -90 to +90. So the angle whose tangent value is equal to 1 in this interval is only 45 degrees. So the expected answer here is 45 degrees. If they want the answer in radian, it will be pi over 4. This question, theta is equal to inverse secant of 2. So since I don't memorize the secant values of the angles, if secant is 2, that means cosine is 1/2. So we're going to think about the angles whose cosine value is equal to 1/2. And then the angle whose cosine value is equal to 1/2 is 60 degrees. And for definition of inverse secant, answer must be in quadrant 1 and quadrant 2 because secant is reciprocal of cosine, and this is still the interval for inverse cosine. Sometimes if you get a value here that you're not familiar through the unit circle, it must be a calculated question. So when they ask you to find the y value, which is equal to inverse cosecant of -3, you will just type on the calculator cosecant to the power of -1 and -3. The calculator is going to give you the answer. If your calculator is in radian mode, it gives you the angle in radian mode, but if it is set to degrees mode, it will give you the answer in degrees. Again, if you get a question like this on the homework, which the ratio is not familiar to you from the unit circle, that means this question must be answered using a calculator. And then on the calculator, all you have to type is arccotangent of, in a parentheses, enter this value, and the calculator is going to give you the answer for this. Just pay attention that you're getting an answer which is matching with the interval for arccotangent. A calculator gives the inverse cotangent value of a negative number as a quadrant 4 angle. The restriction on the range of arccotangent implies that angle must be in quadrant 2. So enter arccotangent is as tangent to the power of -1 over this plus 180. So this is a very important detail. I don't remember if I put any question for arctangent, but if you do see any question on the homework for arctangent, the book says that don't answer the question as it is, just because cotangent is inverse of tangent, and then just put, you need arctan of 1 over this plus 180 if it's a negative number. And then it gives you the answer as the correct answer. There's another tip here. Be careful when using a calculator to evaluate inverse cotangent of a negative quantity. Enter the inverse tangent of the reciprocal of the negative quantity, which returns an angle in quadrant 4. Since inverse cotangent is negative in quadrant 2, adjust your calculated result by adding 180 or pi accordingly. The other question type that we need to learn under this inverse sine function is, they will give us problem nested functions like sine of tangent to the power of negative 1 pi over 2. We will start with the most inner part, and then we're going to only focus here. We're going to call this part as angle theta. So theta is equal to tangent to the negative 1 power 3 over 2. And then if we rewrite this equation, that means tangent of theta is equal to 3 over 2. Since this tangent value is not something we memorize from the unit circle, we're going to actually sketch a triangle and place these values. Arctangent is defined only in quadrant 1 and quadrant 4. If it is positive, that means your angle is in quadrant 1. If it's a negative ratio, that means your angle is located in quadrant 4. In this problem, because this is a positive number, we know that theta is a quadrant 1 angle. Now, if we draw a right triangle like this and place our angle angle theta, its tangent value is 3 over 2. So that means opposite side is 3, adjacent side is 2. So we need to find its hypotenuse using 3 squared plus 2 squared is equal to c squared. That makes our c value to be a radical 13, right? So since we call this whole part as theta, now our problem just changes to sine of theta. So the ultimate goal of this question is, for theta, we want to locate the sine of the angle. So sine means opposite over hypotenuse. We know that opposite side is 3 and hypotenuse is radical 13. And when we rationalize the denominator, this will be the answer we get for sine of theta, and this will be the ultimate result for this question. Another super similar question. When we see this question, we are going to just took this inside part, label it as theta, so that, or angle A. In this problem, they labeled this whole thing as angle A, and then they rewrite the equation as cosine of A is equal to negative 5 over 13. Then they start thinking about the quadrant for angle A. If it was a positive cosine value, we would know that angle A is located in quadrant 1. But we have a negative cosine value, so angle A must be in quadrant 2 because inverse cosine only accepts answers for quadrant 1 and quadrant 2. Because cosine is negative here, we know that angle A is located in quadrant 2. And now we're going to use the values for angle A. So this is what angle A looks like in quadrant 2. And then we're going to draw a triangle. Its cosine value is equal to 5 over 13. So cosine is adjacent over hypotenuse. These two angles are supplementary angles. If two angles are supplementary angles, their cosine value is equal to each other with a sign difference. Or the reference angle for this angle, for cosine A, for angle A, the reference angle is this acute angle here, so you can draw the triangle like this. Adjacent side is 5, hypotenuse is 13, and using the Pythagorean theorem, you will know that this missing side is equal to 12. So now if we go back to question, you just call this whole thing as angle A. The problem changes as tangent of angle A. So you're gonna need the tangent value of this acute angle here, which is opposite over adjacent. Its opposite side is 12, adjacent side is 5. But in quadrant 2, tangent value is a negative number. So the expected answer here is negative 12 over 5. They might even give you the questions in this format where you have more than one inverse tangent or inverse cosine value here in the parentheses. So just call the first one as angle A and call the second one as angle B So if you call this one as angle A, that means tangent of A is √3. And then when you call this as B, that means sine B is equal to 1/3. And this question is asking you to find cosine of A plus B, which we learned in previous chapter. And you will need to remember a formula for cosine of A plus B. It's a formula that you have to use this. By drawing a triangle for each of these angles, you must get the sine value and cosine value for each angle, and so that you can place them in the formula and you can find the answer for this. This will be the last example we go over under 6.1. When we see a question like this, again, you can drop the constant here, and you can just go ahead and label arc sine of 2/5 as B. That makes your sine of B is equal to 2/5. And then this question now is asking tangent of 2B, which requires this formula. And if you have the sine of the angle B, you can draw a triangle and you can find out its tangent value. And then once you have the tangent value, you can plug in that tangent value in this required formula to find tangent of 2B. And this is 6.1.